Okay, in this video, we're going to cover 5.3 using angle bisectors of triangles, the notes, and the homework. Okay, so an angle bisector is a ray that divides an angle into two congruent and adjacent angles. So that means if your angle looks like this, so this is your initial angle, okay, and if I bring in a blue ray, okay, and if I indicate that that's going to divide these two in equal parts, then that blue ray is an angle bisector. And those two angles are clearly adjacent. Okay, the point of concurrency of angle bisectors. Point of a triangle where all of the angle bisectors intersect. And that point's called the in-center. So let's draw that. Now remember, we just did perpendicular bisectors. And where they intersect is called the circumcenter. So this is the in-center. So one suggestion would be to recognize that in-center starts with a vowel, and so does angle bisector. So trying to make an association so that you can remember these different terms. Okay, so let's see what this looks like. So if I draw a triangle, so here's your triangle. And if I bisect each angle, so I'm going to just bisect the angle, make them look like they're equal. So that's a bisector. Let's do another one in brown. Okay, so come in and bisect. And let's do another one, maybe in gray. There's going to be 3 of them. Come in and bisect. And do you see how, if I were to extend these, they would all meet right there? That point, so we'll call that point P, is the in-center. Okay, that's the in-center. So all of those guys were angle bisectors, so let's indicate that. That's an angle that's been bisected. The gray has been bisected, and the brown. Let me just make that bigger. Okay, so I'm going to use 3 here, and I'm going to use 3 there. Okay, all those angles have been bisected. Okay, the distance, when they say find the distance from a point to a line, they really want the perpendicular distance. So the distance of the perpendicular segment from the point to the line. That's the distance that they're talking about. All right, so let's talk about this theorem, the angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the 2 sides of the angle. Okay, if AD is a is an angle bisector, and point D is on that angle bisector, then this distance, remember this is going to be the perpendicular distance, this distance and this distance have got to be equal. Okay, if AD bisects BAC and you have these perpendicular segments, then DB has to equal DC. So they have to tell you that when you draw the line from D to B and D to C, this right angle gets formed. If that gets formed and this gets formed, then I know that BD, so I'm going to say then BD equals DC. Okay? Okay, so now let's do the converse. If, when I draw a distance DC and DB, and I see that they're both equal, and a right angle is formed here and here, then AD must be an angle bisector. Okay, so that's what the converse says. And then in terms of the concurrency, look what's going to happen. So remember, you're dealing with angle bisectors. So the angle bisectors are BP, AP, and CP. P is the in-center. And what happens when I have P as the in-center? Then the perpendicular distance from the in-center to each of the three sides. So this distance, perpendicular distance, this distance, and this distance, provided that they're forming these right angles, so it has to be the perpendicular distance, all those values will be the same. Okay? So that's looking, when you deal with all three, this is what's happening. When you deal with one angle bisector, this is what happens. Okay, so one angle bisector, three in a triangle. Okay, let's keep going. Now here are some examples. Use the angle bisector theorem, find the measure of GFJ. GFJ. So this is the angle that they're wondering about. Okay, what do I see? Well, here's an angle. If this is on the angle bisector, then this will equal this, which it will, when right angles get formed. So therefore, it must be on the perpendicular bisector, on the angle bisector, and therefore angle GFJ has to also equal 42 degrees. Now remember, they could have asked you, what's angle GFH? That will be 42 plus 42, and that will be 84 degrees. So be careful to focus on what they're asking you. Okay, here's example 2. A soccer goalie's position relative to the ball and goalpost forms congruent angles as shown. Will the goalie have to move farther to block a shot toward the right goalpost R or the left goalpost L? Okay, if this goalie is on the angle bisector, which you can see he is, then he will be equidistant. So if he backs up, right, he's going to be exactly equal to either one, provided that we're drawing the set as a right angle, right? So this will equal this. So the goalie is equidistant from each corner. Okay, since he's on the angle bisector. Okay, example 3. Use algebra to solve a problem. For what value of x does P lie on the bisector of angle A? Okay, if P is on this angle bisector, what has to happen is the distance, and that's the perpendicular distance from P to the angle side, they have to be equal. So if that's set equal, then I'm forcing P to be on the angle bisector. So I'm going to subtract x, That gives me 3 equals x minus 1. Add 1, add 1. That gives me 4 equals x. So x equals 4 is the value I need. So look what happens. If x equals 4, then this equals 7. 4 times 2 is 8 minus 1 equals 7. Okay, so watch my steps over here because many of you are not confident doing these two-step equations. Remember, your goal is to get x on one side and numbers on the other. Watch your signs as you do that operation. Okay, so here's some extra practice. Find the measure of angle BAD. Okay, so what I'm seeing is, here's your angle. If this is an angle bisector, what has to happen? Well, the distance, the perpendicular distance from the angle, let me think about this, from the point D, okay, to a point on the angle has to be congruent. So it's formed the right angles, so that's good. If that's the case, then this angle has to be 54 degrees, and is that BAD? Yes. So angle BAD equals 54 degrees, and then also angle BAC equals 54 plus 54, which is 108 degrees. So be careful to make sure that you're answering the question that they're asking. Okay, 3 spotlights form 2 congruent angles. So I have 3 spotlights. Here are the angles. That means that this is on an angle bisector. Is the actor closer to the spotlight's area on the right or on the left? If he's on the angle bisector, then that means that the distance to the spotlights are going to be equal. Okay, so he is equidistant from both spotlights. Okay, that brings us to 3. A, for what value of x does P lie on the bisector? Okay, so if it's on the bisector, so let's draw it so that it would be. Okay, if it's on the bisector, that means that these angles are equal, right? That will only happen if when I draw a line, a perpendicular line, from here to the angle side and from here to the angle side, these pieces are going to be equal if and only if P is on the angle bisector. So x plus 8 has to equal 3x plus 6 because they want to know what x makes that true. Okay, so I'm going to subtract x here. Again, watch this step because this is where a lot of you lack confidence. Okay, so I'm going to rewrite this. I have an 8 on the left. It's a positive 8. So I'm not going to write the plus sign because it's positive. 3x minus x is 2x, and then I have minus 6. Okay, so now I'm going to have this 6 join this 8. That gives me 14 equals 2x. Okay, so I ran out of room. If 14 equals 2x, then get x by itself. X will be 7. And that's what's going to make point P be on the perpendicular bisector. Okay, if it's not, then it would not be on it. Okay, so for what value? So we've got that. Okay, so I'm just looking to see where I am in this. Okay, so then what else does it say? Okay, that's A. So I've got that, and let's just make sure that that works. So if I plug in a 7, I'll get a 15 here, And 7 times 3 is 21 minus 6 is also 15. Okay, so that's going to work. Okay, if AP is 30, using your answer to 3A, 3A was that x equals 7, find AC to the nearest whole number. And they want us to use Pythagorean theorem. Okay, I'm going to draw, let me draw this triangle. Okay, I'm going to draw PCA. Okay, so this is A, P, and C. And this is where the right triangle is. Okay, if I know that PC is 15, what else do I know? And they told me that AP is 30. That's the hypotenuse. So if I know that C squared equals A squared plus B squared, the C squared has got to be the longest side. That's the hypotenuse across from the right angle. So 30 squared equals, okay, let's make this A and we'll make this B. So that's going to equal some mystery A squared, which is what we want, right? We want AC, plus we solved for, if I plug in 7, I know I'm going to get a 15 for PC, so that's 15 squared. Okay, so then I want to get A squared by itself, so I'm going to subtract away 15 squared. That's going to equal A squared. Okay, so do this work. So this is going to be what? 900, and then let's go ahead and we're going to get 15 squared, which is what? 225? 225 equals A squared. So look what that's going to be. That's going to be 675 equals A squared. I don't want A, excuse me, I don't want A squared. I want A. Take the square root of each side, and I'm going to get A equals 26. Now, technically, you would get plus or minus 26, but because this is geometry and your side lengths have to be positive, I'm just going to report A as 26. Okay, so we use Pythagorean theorem to get that. So make a note of that because this section is going to have you use Pythagorean theorem sometimes to solve some of these triangles. Okay, so that brings us to the homework. So let's do that together in this video. Okay, so here comes your homework. Okay, use the information in the diagram to find the measure. So what am I seeing? Well, I am seeing that I have an angle bisector right here. Okay, I have a point D, and this is a perpendicular distance, and so is this. If this is 7, then this piece will also be 7, and therefore AD equals 7. Okay, look at the next one. If I see that these guys are perpendicular, and I see that this equals this, then that means that DB is the angle bisector, and if DBC is 20, then ABD, or DBA, how they have written it, is also 20 degrees. Okay. So then now we're going to look back at this picture. It says, assuming that BC is 15. Okay, BC. Okay, so let's draw that triangle. So here comes the triangle. I'm drawing it from this problem right here. Here is, oh, let's do this better. Hang on, I'm going to take advantage of my ability to draw nice straight lines in here. Okay, here's my right angle. And I know, what do I know? I know that I can label this, right? So this is D, this is C, and this is B. Okay, assuming that BC is 15, Use Pythagorean theorem to find BD to the nearest. Okay, so it looks like what I need to do is I am going to BD. Yes, I'm going to use these values here. That's what they want me to use, and it's not very clear. So, and I need to find BD. So this is your C, right? Because this is the hypotenuse. So C squared equals A squared plus B squared, right? It doesn't really matter because you can interchange those, but let's make A the 7. 7 squared plus 15 squared. Okay, A squared is 49. B squared is 225. So I'm going to add those two together, and I get 9 and 5 is 14. Then the 4 carry the 1, 4, 5, 6, 7, and 2. C squared is 274. So I'm going to just say C is radical 274, and that's not a perfect square. And they want the answer to the nearest whole number. So C equals, let's see, it ends up being 16.55 in my calculator. So what's the nearest whole number? Because this is a 5, I'm going to round up. So my nearest whole number would be 17, and that would be my answer for BD. So BD is 17. Okay, find the value of X. So what's happening here? Look, be on the lookout. I've got a right angle. So therefore, this must equal this if this is the angle bisector. So set 10x plus 10 equal to 8x plus 20. And when I do that, now again, this is another opportunity to see me do this because, as I said, sometimes we need to reinforce our skills here. That's gone, and that's a plus 20. Okay, so now what I want to do is get the x's on one side, subtract 10, 2x equals 10. Get your x alone by doing division, and x will equal 5. Okay, if I plug that back in, just to check, 50, 5 times 10 is 50, plus 10 is 60. 5 times 8 is 40, plus 20 is also 60, so I know I have the right answer. All right, moving on to question number 4. They want the value of x. So what am I seeing? Right angle, equal, equal. This must be an angle bisector. If that's an angle bisector, this has to equal this. We can set those two guys equal. Now, I'm going to move my 2x over here. That's going to give me x's on one side and numbers on the other. Divide by 4, divide by 4. X equals 4. So it's good to plug it back in. 4 times 6 is 24. 4 times 2 is 8, and 8 plus 16 is also 24. So I have the right value for problem number 4. Okay, moving on, we have another page of homework, and this, I believe, is the last page. Yes, it is. Okay, so is DA equal to DC? Okay, what do I have going on? Well, I have that angle bisector. I see I have a right angle formed. Therefore, AD has to equal DC. So I can say yes, because DB is an angle bisector, and DC and AD are drawn perpendicularly. And here's a therefore, AD equals DC. Okay, what about the next one? What do I know? I have an angle bisector, but I don't know if this is a right angle. So I cannot say. So I would need a right angle at A and at C. So cannot tell. So I cannot tell if AD equals DC in that case. Okay, so let's keep moving. Can you conclude that ray BD bisects angle ABC? Well, I've got the right angles. These are equal, so I can say yes. Since we have right angle at A and C, and CD equals DA. Okay, how about this next one? I have these sections equal, but I don't have knowledge about a right angle. So I can't conclude, so it's going to be no, since do not have right angles at A and C. Only have AD equal to DC, which is not enough. You've got to have both. So you have to have this. This is what you need. Okay, you don't have enough for number 8. And that's it. So hopefully that helped. And we can go over this again if need be. But I hope you have a good handle on that.